Let's see how to build an AI chatbot with Next.js, the Vercel AI SDK, and the BigCommerce storefront MCP server. Now, before we get started, let's take a look at what the final product is going to be. You can see here I have a chatbot, and I can type in a random message like hello world, and it's going to get an AI generated response, just like you would if you did the same thing inside of ChatGPT. In fact, this is actually connected to an open AI LLM behind the scenes, so it's going to have similar functionality. But the real beauty of this in building your own chatbot is being able to integrate with other MCP servers and have other things that your chatbot can do. So in this case, I can say something like, what plant products do you have? And the LLM is going to be aware of the tools that it has available to call, one of those being the query products from the BigCommerce MCP. And you can see that it's going to show those products in the results here. So as we go through this tutorial, we'll talk about not only how to build the chatbot, we'll also talk about how to integrate tools from MCP servers, and we'll also talk about how to respond back to a user message with custom UI based on those individual tool calls. Now, there's a few different resources you should be aware of if you want to follow along in this video. The first is the GitHub repository. In this GitHub repository, which will be linked in the description, there is a start branch that you can check out, and it has comments on the individual steps for you to go and follow along with this tutorial. In addition to that, we also have a full written blog post on the BigCommerce developer blog that you can follow with all those exact same instructions as well. And then lastly, a key piece of documentation that you'll want to reference is the Vercel AI SDK. They've got really good starter code on here, a lot of which we've incorporated into this tutorial, but that will always be a go-to reference for anything additional that you'll want to find out and be able to customize your chat experience a little bit more. That said, let's go ahead and get started. All right, so I have cloned this repository locally, and the first thing you're going to want to do is check out the start branch. Now you could explore the final code in the main branch, but to follow along, we're going to start from the start branch. Now, the first thing you want to do is make a copy of the example environment local file. Inside of this file, there are two environment variables, one for OpenAI API key and one for the MCP server URL. Now, I'll have links in the description for you to follow along how to get your OpenAI API key, as well as your MCP server URL for the BigCommerce storefront MCP server. So you can follow along with those and then add those credentials here. Now, I do want to call out that the BigCommerce storefront MCP server is currently in closed beta. I'll have a link if you're interested in applying to join that in the description below as well. This may change in the future, but as of the recording of this video, this is currently in closed beta. Now, the good thing to know is that there's still a lot for you to learn and follow along with in this tutorial. Even if you don't have access to the storefront MCP server, you'll still learn about the core concepts of integrating an MCP server, tool calls, etc. Now, after you have those two credentials set up, you can run the command npm run dev to start the chatbot. Now, if we go and actually see the running example of this, we can type in a message like hello world, but you see that nothing is happening. And this is where we need to take the next steps to actually set this up. Now, if we look inside of our folder structure, you can see we have a page route. So under our app directory, this is Next.js 15. We have our homepage, and then inside the homepage, we basically just have our chat component. That's where we're going to spend a lot of our time. So inside of this chat component, you can see we have some comments and some placeholders here to be able to leverage the use chat hook from the Vercel AI SDK from React. Now, again, this is a lot of boilerplate code that you can reference inside of the Vercel AI SDK documentation. We're going to go through and actually configure this to work. So the first thing we want to do is actually leverage this use chat function. Notice we have hard-coded values here for error, messages, is loading, and status. We can actually get rid of this to do and uncomment this line to use this use chat hook. And then it says we have duplicate values or variables for errors, messages, etc. So let's get rid of those hard-coded values for these three. And we're going to use those values that come from the use chat hook. Now, behind the scenes, what the use chat hook does is automatically, when you call the send message function, it's going to automatically send a message to an API endpoint at /API/chat, which we'll see about configuring in a second. It also handles keeping track of all the messages, and we'll talk more about that as we go as well. Now that we're actually sending this message in code, we can come back to our chat and we can test this out. In this case, we can send a hello world message, but you see that we're actually going to get an error. And if we inspect a little bit deeper, if we go into our network tab, we'll see that we're actually making this fetch request. So if we run this again, we'll see we're making this fetch request to a chat API endpoint, but that endpoint hasn't been implemented yet. So if we actually go and look at this endpoint inside of the folder structure that we have under /API/chat, you'll see that we have our route but we're just throwing an error in here because it's not been implemented. So we can tell on the front end that things are connected in the way that they expect to be. We just have to start to implement the back end to receive those messages, connect to the LLM, and then respond back to the user so that something can be displayed inside of the browser. So if we go back to our route, we'll see we have a couple of comments in here to add a couple of imports. We're going to import the OpenAI abstraction layer from the Vercel AI SDK. This is basically an abstraction to be able to integrate with OpenAI. Again, you should already have your API key already set up. And then we have a few different properties we want to import from the AI package that we'll use to be able to create our actual connection to the LLM and get a response back to the user. So the first thing we want to do is actually retrieve the messages from the incoming post request from the body. And we can destructure this from the object that comes back, and we can give this a type of UI message. Again, this is imported above. And then we get this from the data, the JSON body data from this incoming post request. So we have our messages array, and now we need to actually use those to be able to make a connection to the LLM and pass those to the LLM. So we can define a result, and this is going to come from a call to stream text. That's another function that we imported above. And then we're going to use a model for OpenAI of GPT 4.1-mini. You can make a decision on whichever LLM you would like to connect to. That's what we're going to use in this case. And then secondly, we're going to take those incoming messages from the request body, and we're going to call the convert to model messages function, which takes those messages and strips out some of the data that's not necessary for the LLM to make a decision on. Now, lastly, we're going to return our result to UI message stream response. And this is going to take care of all of the logic for being able to stream that response back to the user. So if we save this again, we should be able to come back into our application and type in hello world. And at this point, we're still not seeing anything, but hopefully we're actually getting a response back. So let's go back to our chat and let's just log out inside of this component. We can log out our messages and hopefully show that we're actually getting a response. Now, if we refresh our page and then open up the console, you can see we have an array of 0 for messages to start. And then as we start typing, we'll see that we're getting messages for the user and then a response back. So if we inspect these, we'll see we have 2 messages. Each of our messages has a parts array. And then inside of each part, you can see what type of message it is. This is a text message that is a role of user, meaning this came from the user's input. And then the second message we'll see has a role of assistant, meaning it came from the bot. And it has 2 parts, the second of which is the one we want to focus on of type text, which shows the response that comes back from the LLM. Now, what are we missing to actually be able to display these messages? Well, the Vercel AI SDK documentation actually has a great example of this inside of the Next.js App Router Quick Start documentation. And if you scroll down a bit, you can see their boilerplate code for being able to do everything that we just did, as well as being able to display messages. And basically what this does is they're iterating through each message. They look at the role of each message, whether it comes from a user or the AI or a bot. And then they also handle each part inside of that message to be able to display that content appropriately. Now, a lot of that logic can get a lot more complicated as you get more detailed, but a lot of that has been taken care of for you in the starter code. So in this case, we can get rid of this to do, and then we can add the message renderer component, and we'll need to import this as well. And this is a component that again comes with you in the starter code that takes care of all that for you. We'll talk about this in more detail in a second, but for now, we should be able to see, if we go back to our chat, that we can see those responses coming back. And we can test this again by saying something like, what is 2 plus 2? And send that request. And then we should see that we get a response coming back. Now, one thing that you may notice is we don't really have a loading state here. Loading is actually already factored in here with this isLoading prop being passed to the message renderer. But you'll notice that our loading is set automatically here to false. So how do we update this? Well, if we look at the status that comes back from use chat, it can be one of 4 different statuses: submitted, streaming, ready, and error. And basically what we want to do is set isLoading to true if the status is equal to submitted and or streaming. And so we can update this here. I'll actually get some IntelliSense from AI, and that should be good. And now if we say hello world again, we should have a loading state in here to show us while it's loading. All right, so we have a lot of nice stuff taken care of for us. At this point, you have the power to ask the LLM anything that you would like to. But again, a lot of the functionality in building your own chatbot comes from being able to connect to other MCP servers. So at this point, let's pivot a little bit to integrate an MCP server into our chatbot, specifically to be able to leverage the tools that it has available to it. Now, in this case, we're going to use the BigCommerce storefront MCP server, but you can use these concepts for any MCP server that you would like to and apply them in your chatbots in other scenarios as well. Now, at this point, you should already have your MCP server URL for your storefront MCP server from BigCommerce. With all of that configured, now we want to actually leverage the client that we have defined in here and add that to our LLM connection to be able to factor that in these responses. Now, inside of the MCP client file under source lib, a lot of this stuff is already taken care of for you. So you can see we have a function in here called getClient. What this does is two things. It creates a transport. This is basically the connection type for the MCP server. In this case, we're using streamable HTTP client transport. And then from that transport, it's going to create a client. And the client is the thing that we can actually query its tools and then assign its tools or share its tools, the list of tools that it has, to the LLM. Now, there's a lot of additional code in here, some things for caching and for session ID. That is a bigger discussion for us to talk about in a later video. For now, you can ignore that and really just focus on the fact that we have the ability to call the getClient function and leverage that client and then be able to use all of its tools. So from that getClient call, we can extract the client and the session ID. And then we are missing the import. So this will import this for us here. So again, this is from lib and then that MCP client file that we just saw. Now from our client, we want to get its tools. So we can call client.tools and get a list of these tools. And then now we can pass this into our stream text function. And what this does is not only will it pass the array of messages as context to the LLM, it will also now pass the context of all the tools that it has available to it and then make a decision on which tool to call. Now, again, this principle is basically the same for any other MCP server that you would like to incorporate. You're going to need to create a client using a transport. From that client, you can query its tools, and then you can pass those tools directly into the stream text function. With this in place, we should be able to test this out. And I know that one of the tools that the BigCommerce storefront MCP server supports is querying products. So I can say, what plant products do you have? And this is now going to pass that context to the LLM. The LLM is going to make a decision on which tool to call, and then it's going to return all of this product data, which is formatted in a nice table with product cards, etc. Now, just as an example for this specific storefront MCP server, another thing I can do is to say, add the spray bottle to my cart. What this is doing behind the scenes is it will create a cart associated with my session. And then you can see that it's created that cart with this ID. Now, an additional tool that you have to call is the checkout functionality. Now we'll see that this is actually going to cause an error, and we'll talk about why in a second. So one of the things we need to keep track of is the user session ID. So the user session. And right now we're not tracking that at all. However, if you see inside of the getClient function call, it actually returns a session ID. So this is attached to the actual transport that we create. And if we look inside of here, we can see that the session ID is attached to a transport after we create it. And then we can use this inside of our built-in caching that is already taken care of for you. Now, the thing that we need to do is actually set that session ID as a cookie and then be able to pass that into the getClient function. So there are two things we want to do. First, we want to retrieve a session ID from the cookie if it exists, and then pass that to the getClient. And then the last thing we want to do is if we haven't already saved that to a cookie, we do want to save it. So we can do this first at the top of our file by getting a reference to the cookie store. And this is going to come from the cookies function from Vercel. So we'll need to import this, or from next headers, excuse me. And then from the cookie store, we can get the MCP session ID from cookie store.get and then mcp-session-id.value. Now, this is actually part of the MCP spec for how you handle session IDs. This is the specific name. So we can look for this, and then we can pass in to our getClient either the MCP session ID or undefined if there is no session ID attached with that cookie. Now, the last thing we want to do is just make sure that gets written to the actual cookie for the future requests that come from the user. So we can say, if we have that session ID, go ahead and write that session ID to the cookie. And then we'll take some defaults here, and you can make decisions on what sort of defaults you want to factor into your cookie storage. So now, if we come back, we should see we first had this error, but let's actually refresh this. Let's start with what plant products do you have? Then we can say add the spray bottle to my cart, and that should create a cart. Also, what you'll notice if you go into your developer tab and look inside of application and then cookies, you should see that we have MCP session ID. So we have that generated and saved. And now if we type in checkout, this should successfully be able to generate a URL for us to go and check out on our store, which is pretty neat. So here you can see we have the spray bottle, and we can go ahead and continue through the checkout. Now, one of the things you may be wondering is how we generate these custom UI components based on the responses from these messages. And the key for this comes inside of the data that's returned in these messages. One of the things that we can tell inside of a message from the assistant is if it makes a dynamic tool call. And in this case, we can see we made it a type of dynamic tool, and then we can see the tool name for create checkout URL. This means we can display different pieces of UI based on the response that comes back. Now, this is already taken care of for you, but this is something that you can dig in and customize as much as you want to. If you look in the message renderer as an example, you can see inside of here that we iterate through each of the messages. And then for each message, we iterate through the parts, and then we either return a user message or a bot message. Now, those components are just wrappers for a piece of content that either highlight it with the user icon or the bot icon. And then if we go into the bot message in a little more depth, you can see we basically do if conditions on the part type being dynamic tool, and then the tool name, and then we display different pieces of UI based on the tools that were called and the data that's returned. So you can abstract this to create any custom UI for any response that you want based on the MCP server tools that you may or may not be integrating with. So that is a high level of how to create a chatbot using Next.js, the Vercel AI SDK, and an MCP server, in this case specifically the storefront MCP server from BigCommerce. If you'd like to apply to be in the beta for the storefront MCP server, there's a link where you can apply below. Otherwise, if you have any additional questions or details that you'd like to see and how to build chatbots, let us know as well.